Here is your homework solution for your homework tonight. This is the actual first question for your response from the 2018 exam. So people enter a line. So do you recognize the type already, right? Is it a table? Is it a graph? Is it a Diffie-Q? Is it a particle moving, velocity, acceleration? You can tell something is adding and something's removing. So we have a line and it's entering. People are entering at a certain rate. And there's another equation might be where they're exiting at a certain rate. But here it is. From 0 to 300 is measured in people per second, and t is measured in seconds. So as people get on the escalator, the exit line at that constant rate. So that is our second one. There are 20 people in line at t equals 0. So from 0 to 300 seconds, this is the rate. And then after 300 seconds, 0. No one keeps adding to the what's happening. No one is going onto the escalator. All right. Part A. How many people enter the line for the escalator from 0 to 300? So how many we integrate from 0 to 300? So we only integrate the top part. So I'm going to integrate from 0 to 300, just the top line. So again, I'll show you in terms of it. And again, I'm going to model what I think is best for you. So we're going to go back here. If you have something, which I do, I'm going to go 1 and then 4 and delete it and start from fresh again. And so when I come back here, I'm going to, oops, that's not what I want to press, tab. I'm going to type in that first equation. So it's 44 parentheses. I'm going to use x over 100 to the exponent 3. Move the cursor, parentheses, 1 minus x over 300 to the exponent 7. I don't care about the graph, but I have it defined now. Now, in the second equation, might as well just type it in. The second equation is a constant 0.7 persons. So it's just 0.7, constant, just a constant number, which is 0.7. So there's the second one. That's the amount of, in terms of people exiting the line. Okay, so F1 is entering, F2 exiting, and that's in my calculator. The first question again was to integrate. So menu calculus integrate from 0 to 300. So you don't have to retype it in. It's the first equation, F1 at x, dx, and that's it. Control enter, and I get the answer 270. So the question is, how many people enter the line? And the answer is 270 people. That's A. Part B. During the time from 0 to 300, there is always people in line for the escalator. How many people are in line at time t equals 300? So there are 20 people to begin with, so we need that 20. How many people have entered? 270, and then subtract the removal part. So when I'm doing that, I'm integrating from 0 to 300, just 0.7. All right, let's type that in. So that's the equation. So we started with 20. We just found out from 0 how many people are added to the line, 270. And then subtract the removing. So that's integrating from 0 to 300. The second one, which is F2 at x. And then control enter. And there are 80. So the second question is, how many people are in line at t equals 300? And the answer is 80. What you started with, what you added, and what you subtracted, and put it all together. Part C. When t is greater than 300, what is the first time t that there are no people in line for the escalator? So we're not adding anyone after 300. So right now at 300, we have 80 people. We know that they are removing at this rate. So the question is, at what time is there no people using this rate in terms of what would happen? And then I would solve for that one. Now, if I integrate 0.7, it's just 0.7, in this case, x or t. It's just a constant, so just put the letter there. And I want to know when that answer is ultimately 0, when there's no one left there. So then I'm just going to solve that equation. That's it. I don't need to type any more now. Menu algebra solve. And I have 80, subtract 0.7, you can use t, equals 0, comma t. And I get 114. Now I'm going to add that to 300. So this answer is 114.285, but that's after 300. So if I add all that together, this is the number I get. So at t equals 414.285, at that point the answer is 0. We could also set up an equation to solve here. I shouldn't really use x. Let me see if I can type that in. So 80 subtract, oh wait a second, I'm solving an equation. So menu algebra solve, 80 subtract, I'm going to use like k instead of x, a different letter. And then I'm going to integrate, menu calculus integrate. I'm going to integrate from 300. I'm going to call it k, whatever that number is. And the rate is just 0.7. And that's equal to 0. Let's see if this works. Maybe it won't. And then solve for k. Ah, did it. Look at that, right out the bat. So it gave you 414.285. Man, isn't that sweet? Anyway, I like it. Last one, part D. From 0 to 300, at what time is the number of people in line a minimum? So how do we find a minimum? Is we take the rate and make it equal to 0. Now, we have two rates. So we have this rate, which is the rate of people entering the line. And then we have this rate, which is the rate exiting. And I want to know when that's minimum. So first, I'm going to make it equal to 0. I want to know when you take the derivative. This is already a derivative. It's already a rate. And we want to know at what time is the number line a minimum. So you take the rate entering, subtract leaving. I want to know when that's equal to 0 from 0 to 300. Now, we already have it defined in here. So that's what we're going to do. You're going to go menu, algebra, solve. So R in my calculator is F1 at X. Subtract the second one. I can call it F2 at X or 0.7. I want to know when that's equal to 0. And I get 33 and 166. So I'm going to do a table of values. So the beginning time is 0, both ends of the endpoints. And then I found 33.013, also 166, 0.574, and then the other end, which is at 300. To all of these, I'm going to plug in and see what the answer is, and whichever one answer gives me the smallest, that's the answer. All right, so how do you know how many people are in line and what's the minimum answer? So we start with 20 in line. So there's 20 right there. The next one, we're going to go 20, and there's two parts to it. So we have to integrate from 0 to 33.013. So that's going to tell me how many you're adding to the line. And then subtract, and I'm integrating 0 to the same number. And then this is my second one. Removing from the line, and see what that answer is. Once I have it set up, I won't have to type it in over and over again. So 20 plus, we're going to go menu calculus integrate from 0 to 33.013. Now the first one is F1 at X. Those are the ones entering the line. And then subtract, we're going to integrate, menu calculus integrate from 0 to 33. And again, once I have this set up, I'm just going to change that 33 number. The second one, which is F2 at X. And then see what the answer is. And if you round it to the nearest whole number, this rounds to 4. So now we have 4. Now we're going to do the same work and just change that number to 166. So highlight over it, press enter, and then just go back and change it to 1. So I'll change this one first. $166.574. Change the second one to the same thing. 166.574, and then go Control Enter again, and now it's 158 people. And then we already know at 300, how many people were there at 300? There were 80 people. We already solved that one. And so when is there a minimum? So at t equals 4 seconds, there's a minimum of people waiting in line in terms of that, which is at 4 people, right? And then how many people? Which is 4 people waiting in line. And that's it. You did it. Mr. G Math, over and out. Good job getting your homework done. I'm proud of you. Let's keep going. Until next time.